just two things I want to explain you. So say you have one series circuit, okay? You have a battery here, this is the negative terminal, positive terminal. You have one resistor here, say R2, the value is 3 ohms, okay? This is 6 volts right here. And then you have, this is going to be R3, and this is 2 ohms, okay? This is terminal A here, this is B terminal. The voltage across this terminal is going to be VAB. You have another voltage source here, okay? And then you have another resistor here. You have another resistor here, and then this goes here. So this is your R1, which is 3 ohms. R2, R3, and say this is your R4, and the value is 3 ohms, okay? Now remember, just like we were applying KCL in nodal voltage analysis, in mesh current analysis, you are going to apply KVL. It is a process that uses KVL to determine loop currents, and loop currents are assigned to independent loops, okay? Notice here you got, how many loops you got here? You got one loop here, correct? This is your loop over here, and you have to decide what is going to be the direction of the current within that loop. And usually, you know, we go with clockwise direction because it's more natural to us as human beings, okay? So we're gonna assume that current is gonna flow in clockwise direction. And based on that, again, remember, what was KVL? The sum of all the voltages is equal to 0. 0 within the loop. Okay, all right. So I'm going to start off from here. Okay, I'm going to start off from here. You have to pick your starting point. I'm just going to pick over here. And also remember, you know, when you have a resistor, okay, say R over here, and you have some voltage source over here, the voltage is gonna be a drop. There's gonna be a drop here, correct? This plus minus basically indicates that, say you have Vs here, there's gonna be a voltage drop across this resistor, okay? All right, and at this point, say this is your V out, is going to be Vs minus whatever the voltage drop across this, say this VR, so it will be VR, okay? So when you are moving clockwise, and I'm going to pick up this starting point right here. So clockwise would mean I'm going to go this way, okay? And then go this way, and then go this way, okay? I see the polarity of the power source is such that I'm going from negative terminal to positive. So we would consider it as a boost, okay? So think of it as you are climbing up to the hill, okay, from negative to a positive position, okay? And if you're gonna give it some magnitude or some value, so this is 6 over here, correct? Okay, and then we're gonna again remember, this is going to be plus minus, because the resistor there is a voltage drop, plus minus, then you have the plus minus over here, so I have plus minus here, and then plus minus here, voltage drop across each of those resistors. Now I have I'm here, now I have R2, okay, and then there's going to be plus minus. So 6, we started off at 6, it was going up. When you are going up, you just keep on adding values, okay? So you just add. But when I get here at this point, I see there's a resistor over here, so the voltage is going to drop. So voltage drop is going to be considered as that you are climbing down the hill. So basically you will go down. So you have positive here and you have negative here. When that's the case, you subtract the values, okay? Correct? Okay, so 6 minus, what is the voltage across this R2? Say this is a series circuit, so there's only one current here, because in a series circuit, current remains same, and I'm just gonna label it as I, and I can simply apply Ohm's law to find out the voltage across the resistor, which will be I times R2, right? Okay, now I'm here. Okay, so now I get to R3 and I see the polarity plus minus. There's going to be a voltage drop here. Again, voltage drop would mean we are going from plus to minus, which means, you know, climbing down the hill. So we are going to subtract it. So this will be minus I times R3. Okay, so now I'm here. I see plus to minus here, correct? So again, minus, and also what is this is 15 volts, okay? So minus 15 here, minus 15, then I have plus minus here again. So this will be I times R4. I'm here, and then again the polarity is plus minus. So again, climbing down the hill. So that means we are going to subtract it, minus I times R1 equals to 0. The sum of all the voltages is going to be equal to 0. And because we have negative sign here, because we are going down the hill, so we're going to subtract it. So in other words, you know, say this is your 0 point right here. You went up and then you went down. Okay, so resultant is basically 0, correct? Okay, now here we can, you know, so say we can put the values here, 6 minus IR, R2 is how much? R2 is 3 minus R3 is how much? 3, and then minus 15 minus R4 is how much? R4 is 3 also, and then minus I times R1. R1 is also 3. Yeah, and actually R3 was 2 here, 2 ohms, and R2 was 2. Yeah, so equals to 0. So if I open this equation, I get 3I minus 2I minus 15 minus 3I minus 3I, right, equals to 0. If I do the math here, minus 3 minus 2 minus 5 minus 5 minus 6 is minus 11. 6, so minus 11I, right? And then 6 minus 15, this 2 is going to be how much? Minus 9, right? So minus 9 minus 11I equals to 0. 9 is going to be, minus 9 equals to 11I, and then I is going to be minus 9 over 11, correct? So I get the value of current over here. And then once I have this value current here, I, if I need to find out VAB, that would be just equals to I times R3, because whatever the voltage across R3 is the voltage across A and B, okay? This I you get from here, and then R3 would be the, okay? So just remember, within the loop, we'll be driving equations. And how do we go about it is I just explained it. You know, just think of like climbing up the hill when you are going from negative to positive. And then when you're going from positive to negative, you just subtract all the values. You have to make sure that you going clockwise. You have to be consistent. You can also do this counterclockwise. You will still get the same answer, but it's just you have to be consistent. Okay, another thing over here, consider you have a circuit like this. So say you have a parallel circuit, you have a power source here, you have resistor here, and then you have another power supply here, and then resistor here, okay? So say in this, you have 2 loops here, right? This circuit is different than what you had over here, right? Here you only had 1 loop, okay? In this circuit, you have 2 loops, 2 independent loops, one over here, one over here, okay? With each loop, there is a current associated with, okay? So say, I'm gonna say the current in this loop is going to be I1. The current in this loop is going to be I2, okay? All right, now, I'm going to apply mesh analysis in this loop first, okay? So loop I1, loop I1, okay? Again, remember I am looking at this loop right here, okay? And say this is some value VS right here. This is R1, this is R2, this is R3. Okay, so starting point over here. So say I'm starting from here, negative to positive. Okay, I have negative here, positive here. So Vs, positive Vs. Then I have plus minus here, and then I have plus minus over here. Okay. So I will have minus I1. The voltage across this resistor is going to be I1 times R1, correct? And then so I'm here now. Now I need to go this way. So here when I get to R2, the problem is in R2, it's not just I1 which is flowing in this direction. I also have I2 which is flowing this direction. So I1 going down and I2 is going up. So they are opposite of each other. And because I'm looking for equation, loop equation for this loop right here, so we would assume that a current one has higher potential than I2. So the current flowing is going to be the potential, actually the difference of those two currents. So it's going to be I1 minus I2 times R2, okay? So just keep that in my mind. And similarly, if I am making the equation for loop I2, okay, for this loop right here, okay, the current across this R2 will change. This time it will be I2 minus I1 times R2, okay? Because remember, I2 is flowing upward and then I1 is flowing downward. But because this, we would assume when we are referring to I2 loop, this loop right here, the I2 will have higher, potential than the I1. So it will be I2 minus I1. Okay, so just keep that in mind while we do this example now. So this was just the basics. What do we have to do here? Find current in each loop, determine the voltages current across each circuit element. We also have to solve for loop current KVL equation for all independent loops and then solve. So if I ask you like how many independent loops do we have here, can anybody give me a quick answer? Yes, folks. How many independent loops do we have over here?
3.
3. Good. Okay, so I'm gonna say this is my loop 1. Okay, and I'm gonna say the current that's flowing in this loop is say I2. Okay, the current that's flowing in this loop right here. Again, you have to be consistent with your direction of the current, clockwise in all the loops, counterclockwise in all the loops. Okay, you choose. I'm usually gonna go with clockwise throughout the whole course. So this is going to be say I1, and the current that's flowing over here, I'm gonna say this is my I3. Okay, the value here, this is your R1, this is your R2 resistor here, this is your R4, this is your R3. You have 2 voltage sources, actually 1 voltage source over here, that's the polarity, and you have 1 current source over here. Okay, so it's in this direction and it's 5 milliamps. Okay, all right. I'm gonna start off with the loop current equation for I1 first, which is this one right here at the top. Okay, loop I1. Okay, remember the direction of the current is just clockwise. So if I start off from here, okay, so I get 15 negative to positive, right? Negative to positive. So that's going to be a climbing up. So this will be positive number 15. Okay. Now this goes through a resistor. So you will have plus here, plus here, minus here, correct? It's going clockwise. When I get here, can anybody tell me real quick, what will be the current over here? Yes, folks. Remember here, you have I2 flowing in this direction, and you have I1 flowing in this direction. So what would be the current across this resistor, R2? Come on, folks. If I say I1 minus I2, is that correct? Yeah, it will be correct. Okay, because remember, you have the current I2 and you have current I1 both flowing through this resistor R2, which is 2 kilo ohm, but in opposite direction. And since we are working on the loop I1, we assume that I1 has a higher potential, so the current will be basically the difference of I1 and I2. So I will have I1 minus I2. Okay, and remember, the voltage is just basically IR, right? So I here is I1 minus I2, and then I have R2 over here, um, R2 over here. Okay, now I'm here now, and I'm gonna move on to this now. Again, we have plus to minus, so that means we are climbing down, so negative sign, and then current. What would be the current across this resistor now, folks? What is this current that's flowing here? Yes, folks. Anybody want to guess? That's okay to be wrong. Across R4, what is the current that's flowing? So across R4, the current that's flowing is I1. Okay, that's the only current that's flowing through. So I will have I1 over here, and this is basically 1K. Okay, let's plug in the value here for, actually, you know what, instead of, I'll just write R4, and then next step I'll plug in the values. It's going to R4. So let's plug in the values. Voltage source is 15 already, and we know that 15 minus, so I1 minus I2, this is something that we have to find out. R2 is 2 kilo ohms, okay? And then this is 1K, right? So 1K I1. And if I, just for the sake of simplification, divide this whole equation by 1K, okay? So I will get what? So this will be 15, right? 15. And this will be milliamps, correct? Okay, because 15 divided by 1K, when the K goes to the denominator, it will be negative to the power 3, negative 3. So, and then here, this K and will cancel out with this K, correct? So I will get what? Negative. So maybe I can open the brackets here. So this will be negative 2I1 plus 2I2, correct? And then this K will cancel out with this K, and I have I1 here, okay, equals to 0, right? So this was equals to 0. Okay. Now, if I rearrange the equation, I basically get this 15 milliamps equals to, I will have 3I1 minus 2I2, okay? 15 milliamps to, okay. Yeah, does that look good? Okay, and I'll say this is my equation 1. Okay. Okay, all right. Now let's work on loop 2. Loop 2, okay, which is this one right here. Okay, and I am going to start off by from this node, right, this here, okay? So again, can I ask you guys what is going to be the voltage across this right here, this resistor, 2 kilo ohm? Again, you have all these resistors here, correct? So current always flows from a potential of higher to the lower. So that's how the polarity is gonna be. So again, the current flowing here is only I2. So I would have I2 times R1. Maybe I can change the color here. Yeah, I2 times R1, okay, plus, then we are here, right? This time around, the current across the R2 is going to be the I2 minus I1, okay? So I get I2 minus I1 times R2, and then I go here. Okay, what is going to be the current across this? The current across this resistor is going to be I2 minus I3. Remember, I2 is going this way here, and then I3 is going this way. That's why you're taking a difference, because they are in opposite direction. So plus you have I2 minus I3 times R3 equals to 0. Okay, now let's plug in the value for all the resistors. R1 is how much? 2K. So I get 2K, 2K I2, okay, plus R2 is how much? R2 is 2K also. So 2K I2 minus 2K I1, okay, plus R3 is how much? 4K, 4K I2 minus 4K I3. And then this equals to 0. And just for the sake of simplicity, what I'm going to do, I'm going to divide this whole equation by 2K. Okay, so if I do that, I get what? I2 here plus I2 minus I1 plus 2I2 minus 2I3 equals to 0. Okay, and if I rearrange this equation, I would get what? So 4I2, I2 plus I2 plus 2I2 will become 4I2, okay, minus I1 minus 2I3. Now, I3 is the current which is actually flowing in this loop right here. Notice here in this loop, you also have an independent current source, which is 5 milliamps, right? Now remember, whenever you have within a single loop like this, within an independent loop like this, whenever you have a current source, the current that's flowing in that loop is going to be what you have the current source. And because this is 5 milliamps, so I3 is going to be 5 milliamp in this loop. Okay, so the current in that loop is going to be 5. So here I'm going to put that value. I3 is equal to 5 milliamp. So again, if I rearrange this equation, I basically get 4I2 minus I1 equals to negative 10 milliamps. Okay, now I was going to say this is my equation 1. Okay, actually this is going to be equation 2 because we have the equation 1. So we have one equation over here. Okay, we have one equation over here. Now I'm going to work on loop I3. Okay, I3, and this was pretty simple. Loop I3, we already know I3 equals to 5 milliamps, so we didn't really have to come up with an equation. We can just say that I3 equals to 5 milliamps. Now, simultaneously solving for I1 and I2 using equations 1 and 2. 1 and 2 here, okay. I have my equation 1 over here. I have my equation 2 over here. Okay, so I'm gonna rewrite these equations. Okay, so 3I1 minus 2I2, okay, equals to 15 milliamp. That was equation 1. And then I have 4I2, and if I actually rearrange this, I1 plus 4I2 equals to negative 10 milliamp. Okay, so that was my equation 2. Okay, again, we are gonna have to look for making the coefficient same. So if I here multiply this equation 1 by 2, which would mean this will become 4, and then this is already 4, so we can cancel out. So 3 times 2 is 6i1, right? Minus 4i2 equals to 30 milliamps, correct? And then just rewriting this equation right here, the second one, negative i1, I have plus 4i2 equals to negative 10 milliamps, okay? So this will cancel out. 6i1 minus i1 is going to be 5i1. 30 minus 10 milliamp is going to be 20 milliamp. So I1 is equals to 20 milliamp divided by 5. So that is 4 milliamp. Okay, all right. Putting I1 in equation 1. Okay, so let's rewrite the equation 1. 3i1 here minus 2i2 equals to 15 milliamp, right? I1 is 4 milliamp, so I'm just going to say 4 milliamp here. Okay. Minus 2i2 equals to 15 milliamp. Okay, 3 times 4 milliamp is 12 milliamp. Minus 2i2 equals to 15 milliamp. And then 2i2 is going to be equals to negative 3 milliamp, correct? So I2 is going to be negative 3 milliamp divided by 2, so you get negative 1.5 amps. Okay, so I got my I2 here, I got my I1 here, I3 we already had determined over here. Oops, over here, here. And now that we have the these currents flowing over here, we know I2, we know I3, we know I1. What we could do, the voltage across this resistor R4 is going to be, say, V4, I1 times R4. I1 is known now, right? Similarly, this V1, the voltage across R1, is going to be I2 times R2, correct? So with this, you should be able to find out the voltages, and using those node voltages, you should be able to find out these node voltages over here also. And also, I just wanted to make sure one thing that I forgot about. This I3 right here is actually going to be negative 5 milliamps. And the reason for that is, if you notice, the direction of the 5 milliamp is actually this way, correct? But we consider in our analysis that I3 is going to flow in clockwise direction. And because that direction is opposite to that of the current source over here, therefore we're going to have I3 equals to negative 5 amps. Okay, all right. And then from there on, you can plug in the values for current and voltages, and then find out the voltage and across each component. So I hope you enjoyed this tutorial. Thanks again for watching, and don't forget to subscribe to the channel if you haven't already.